So welcome guys. So now I am start new question. So my question name is Flatten BST to sorted list. This question is based on BST. So this is very important question related to DSA. So this is middle level questions. You can see in GFG. So simply search flattered BST to be sorted. Okay, let's start to read question. So first line, you are given a BST tree, binary search tree with n nodes. Okay, you have a number of nodes. Each node has distinct value assigned to it, and every node has a different value. So the goal is to flatten the tree such that the whole goal is that such that the child of each element point to be null and the right point to the next element in the sorted list of element list in BST. Look at the example for clarity. Uh, so this line is simply said that we simply create our goal is that we simply we don't need to pull the left child, we only fill right child of the node. As we can see that the left is null and we will fill the next node into the right child. Next is to left third second left is null, next filled into the right child. Okay, this line is also said that uh, left child of the each node point to be null. So as I said that it is point to be null, and the right child point next element of the sorted list in BST. Okay, I hope you clear this point. So overall, you must have a accomplish this without using any extra space. Means we solve this question without and use any extra space like any extra array vector like that. So except for recursive calls. So we can also, but we can use recursive call, so which are allowed. So we can use also recursive call. So not if your BST does not have a left child, so then the system will print a minus one and will skip it, resulting in a incorrect solution. This means that simply that if we don't um, we manually, if we don't put manually null this left side, so the system automatically given minus one. Okay, so overall our question is PST, and we solve this question in such a way that we have a given a tree like this, and our output is like this, flatted tree. This is called flatted tree. So that's why the question is flatted PST. Okay, now we will see input. What is input? We have a binary tree BST, binary search tree, sorry. As you know that binary search tree in middle, it is a high, it is a in root node. In the root node, in root node there is a, small element in left side and bigger element in right side. So as we can see that this is our output. So uh, let's suppose how it will be possible to print this output. I can simply say that it is a pre-order of this PST. As you can, pre-order is that orders in which we have root, we have root in middle and sorry, not pre-order, it is in order. It is a totally in order. Output is a totally in ordered sequence. So we simply say that we traverse this tree through in orders. Okay, so this is the two In order tree traversal, we simply go to the left side and then print, then back, then print middle, then right one, then back, middle, then left one, then middle, then right one. Okay, let's see in the notepad and see how we tackle this question. Okay, so this is our binary tree structure. Okay, so our aim is to find such to find that to find uh, in order traversal. And one more thing, we have to return one element. So we clearly take. So as the function, our task is you don't need to read the input and print anything. Your task is to complete these functions which take root node of the BST as the input parameter and return a root node after transforming the tree. This simply means that return the node after traversing tree. So in simply we can say that in order traversal we simply print that element. So we got a pre-order in order in, in BST. So but in this case we have to return such element that we got this series, this output series. So we should return these two element. After that system automatically print all the element, all the output. So we have to remember these things, so that we have to return node root node. Okay, so we have to think this question. There is a two approaches. So we simply traverse this PST through in order traversal. So and store into array. Okay, array. Sorry. So this is store into array. After storing all this element into array, the simply we put into the one node and simply say that if its node left is null, point to null. Okay, and right element root right. Okay, and root right simply point array of I, and we simply say that uh, to change the root element into right, root is equal to right. So simply this logic is also correct. You can also perform this logic. This is simple logic. So but in this case the space is little bit big of and so in our questions it is simply said that we don't use this extra space, we we use only recursive space. So in recursive, this is the space complexity is big of h means height of this tree. Okay, this is simple approach. No we will jump into uh, next approach, recursive approach. So let's move this part up. Okay, so let firstly we take a global variable name global node variable. Okay, node variable is equal to previous. Okay, so this is previous. So after that we create a node. We don't need to. Okay, create node, new node. Okay, create new node. Let's suppose -1. This is create a new node. Okay, after that we point this node into this for recording. Okay, this is the channel for solving our question. So because you have to record, you have to record of the first node that you print. So after that, let's go to the main function. Let recursive call. Okay, so simply uh, use one function in order. In order. Okay, sorry, but I simply read that and pass root node. So this is in order. Sorry, but my writing is not good, so I am using not notepad. That see, this is the root node. Okay, so as we print in order. So first cursive goes into this. After that, this, yeah, na, and after that goes into right. But here we got null. So it return, na. So after return from this, we simply said that, as I mentioned, that previous is global variable. So previous we can use anywhere in the method or class. So previous left is equal to null. Okay, so in this we said that previous is equal to null and previous right is equal to right is equal to root. So if it return, then the root is this 2 is root and we simply store into right part of the previous. Okay, so after that, then this is the previous. So we have 2. Okay, so we simply made it previous. We change the value of previous into this 2. Okay, After that it return this part. Root is this. Simply we also perform this left is equal to null and right is equal to root. Root is 3. So we form another root, another node 3, right? Okay. So and simply uh, point previous to this root. Okay. After that we call into left side. Okay. If we return from this, it is also go call from right side, but it is not no there is a no right side, so that's why it call return. If it is right side, then it call right side. Okay, this is the root. So simply previous is left and right is root. So simply push into previous into right is equal to root is equal to 4. After that uh, it goes this and after got this is 5. So after this is 5, this point to 5, this step, all this step is covered from through the recursion. So this over recursion. So as we can see that was outputted 2 3 4 5, 2 3 4, next one is 5, next one is 6 7 8, 6 7 8. So let's see the code. Okay. As I mentioned that we declare a global variable previous. So this is over function that is given from the system, and they give us the root node. Okay. So this in this case we got a 5 who has a root node in this. Okay. So we create a dummy node, new node, dummy node, so -1, and we simply point this node previous into this node. Okay, for record we will see how what is the main aim of this doing this. So okay, we simply call this in order function. Let's go to the in order function. So this is in order and passing root node. So if root is null, so there is no condition for null, so the code either function is terminal and return. Simply mean that if we also write this in a way such if root is equal to null, then return. This is the same like that. If root is not null, that then the condition is, then this condition is run. So this is root is not null, so this is 5, so that's why it is not null, and this is it goes to the left side. So whenever it goes to left side, this is 2. It goes from this to this to this. After that it goes to null, but when it is null, root node null, there is no condition, then it just goes back automatically. It is goes back, and then root node is 2. Okay, then previous left is null, previous left is null. Okay, previous left is null, and previous right is root. Previous right means previous right is 2, previous right is root is 2, so that's why it is 2, and previous is equal to root is 2. So this is now previous and this is previous right. Okay. After that right side, we will check into right side. So after that it is right side, there is a no element, so it return back and return back. After that it goes into 3 and after that it check, it simply put previous left is null and the right is equal to root is 3, so that why it put right, and previous is equal to root, then now previous is 3. Okay, and after that it check into right if there is a right element. So yes, there is a right element 4. So after that we root node is 4. So after that root node, so after same condition is same step is follow, this three step is follow, and recursive call each function. So this is the main logic, main code behind this question. So after this we got this type of tree. Only left side is filled, not left only right side is filled, not left side. Okay, so after that whenever we go in the last element, we are either we are in eighth place. Our previous node is in eighth place. So we simply previous left is equal to null, and there is a no element. So that's why we simply return that previous right is also null. So return, this is the that condition that I mentioned that we will see in future. So this is the conditions. New node is equal to right. So as I said that we create new node and put the value new node into previous. So previous goes into line 2 into the last, but new node there don't new node is not change their position. So that's why there is a element new node. His condition is -1. So after that this after that its right side is 2. So to simply print new node dot right. So this, let's run this code and check what is set. So it pause all the cases. This is the input, this is the our output, and expected output is same. So let's submit this question and check what is the output over getting is true or false. So it passes all the cases. So that's why it clear all the cases. So this is the logic behind this questions. I hope you like it, and please like and share my video. Thank you.